Okay, so we are talking about perpendicular bisectors today. Okay, 2 words. Perpendicular means it makes what kind of angles?
Perpendicular.
Right angles. And then a bisector means it cuts something in half. Okay, so the first thing that we're going to fill in here, the first blank, is a perpendicular bisector. Okay, a perpendicular bisector is a line, segment, or ray that passes through the midpoint, that's the next blank, of a segment and is also perpendicular to that segment. It's in the name, perpendicular bisector. Right angles, cuts the segment in half. Okay? Then this first theorem talks about the perpendicular bisector theorem. It says if a point is on the perpendicular bisector of a segment, then it is this word we call equidistant. And it's shut out for me, didn't it? Try this one more time. Okay. The blank is E-Q-U-I, distant. Okay, equidistant. That means equal in distance from the endpoints of the segment. Okay, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so we're looking at our picture over here, and it says if CD is a perpendicular bisector of AB, so look here's CD, okay, that I'm highlighting in yellow, and it is the perpendicular bisector of segment AB. And how do we know that? Do you see the right angle markings in the picture? That means it's perpendicular. And then do you notice how it says that AD is congruent to DB? That D is in the middle because of those 2 congruent markings. Do we see that in the picture? Okay. What that means then is that the distance from A to C, so AC, is going to be the same as CB, or is going to be equal to CB. The length of AC is going to be equal to the length of CB. And without having drawn the picture, this is kind of what it looks like. Here's my segment AB, and then we're told that CD is a perpendicular bisector. Okay, that means those 2 are congruent. And then what this theorem says is that this point that is on the perpendicular bisector, it lies on that line, is the same distance from either end of my segment there. Does that make a little bit of sense? So if I give you a picture, something along the lines with these markings, and I said that AC is 5, and I wanted to know what CB is, what would you tell me? It'd be 5, okay? It's the same distance. And then the converse of that is also true, okay? So that says if a point is equidistant again from the endpoints of a segment, then it is the perpendicular bisector of that segment. Okay, so basically it's just switching this around. It's telling me if AC is congruent to CB, okay, or if the length of AC is equal to BC, then C lies on the perpendicular bisector of segment AB. And so therefore then I would know that that line forms a right angle and makes congruent segments there. Okay, so I could give you the same thing but backwards. If I had these in my picture, and I said that this was congruent to that, and I told you that this was 4, and I asked you for this segment, what would you tell me it is? 4, okay. So if these two are the same, then those two are the same. Or the other way around. If these two are the same, then those two have to be the same. That's what that theorem says in the converse of it. Everybody okay with that? All right, so let's take a look at that first picture. Pay close attention to your markings. What kind of angle is marked right there at angle G? A right angle. And then what does it tell me about segments EG and GH? They're congruent because of those markings. So if I wanted to find EF, like my question is asking, I have to solve for A, which means I'm going to have to set up an equation. What would I do? What could you tell me about EF and HF? They're congruent, yes. Because F is on this perpendicular bisector, that means EF is going to be equal to HF. So then I can plug in what they told me about those and solve for A, so that I can then go back and find the length of EF. So what would my equation be? Exactly. 4A minus 15, the length of EF, is equal to A plus 12, which is the length of HF. So what we need to do is we need to solve that equation for A. You need to pick your head up. You need to get a pencil and you need to take notes. So we should solve this equation for A so that we can go back in and find out what EF is. I personally would subtract my 1A over to my 4A first. That doesn't necessarily mean that's what you have to do first. That would give me 3A minus 15 equals 12. So what would I do next? If I want to get that 3A by itself, what do I do? Add the 15 to both sides, yep. So that's going to give me 3A equals 12 plus 15 is 27. And then what? And so A is equal to 9. But is that what they asked me for? Did they ask me to find A? They asked me to find EF. So what is EF represented as? 4A minus 15. So what I'm going to do now is I'm just going to plug in that 9 for A and find the length of EF. So 4 times 9 gives me, and 36 minus 15 gives me 21. I want you to go ahead and try the next example. Basically the same stuff. They might give you a little bit different information. But remember, if you're told these are congruent, then these two are congruent. If you're told these two are congruent, then those two are congruent. Actually, this one shouldn't take very long to do. There's no variables for me to solve for, is there? So if you look at our picture, we're looking for XY. But if you look at our picture, do we notice that WX and WZ have the same length? Okay, so what that means is that YZ and XY are going to be the same. So what would XY be? 22.4. Okay, so that one wasn't too terribly difficult. You just had to look at the picture. Anybody have any questions? Okay, so now we're getting into a part of this. We're going to be talking about several different segments, like perpendicular bisectors, medians, altitudes, and lost my train of thought. Perpendicular bisector, median, and altitudes, and they all have and angle bisectors. They all have points of what we call concurrency, which we'll explain in just a second. You're going to have to remember which one goes with what. And there we go. So what we're going to be talking about is these perpendicular bisectors of triangles. Okay, we're going to start talking about these points of concurrency. So when 3 or more lines intersect at a common point, the lines are called, hold on, my pen's not writing. Concurrent lines. That part isn't really a big deal to remember. But the point of intersection, the point where those concurrent lines intersect, is called, this is important, the point of concurrency. Okay, the point of concurrency. Each segment that we are talking about, perpendicular bisectors, medians, altitudes, and angle bisectors, have different points of concurrency, and we are going to have to remember them. Some of them have certain rules with them, some of them don't. Okay, but this stuff is important. You will be asked questions on these on your quiz. So, how many sides does a triangle have? 3. And so, since it has 3 sides, it also has 3 perpendicular bisectors, okay, because each side is going to have a perpendicular bisector. These bisectors are concurrent lines, which we just defined up front or up top. And the point of concurrency for perpendicular bisectors, okay, the point of concurrency for perpendicular bisectors is called the, what we call circumcenter, okay? Circumcenter, the point of concurrency for perpendicular bisectors, is the circumcenter of a triangle. Okay. All right. Now, on the back, we are talking about the circumcenter of a triangle. And this theorem says that the perpendicular bisectors of a triangle intersect at a point called the, again, circumcenter. And the important part about that is equidistant from the vertices of the triangle. Vertices is plural for the vertex. That would mean the angle of a triangle. Oh, I forgot my R up there. Or I didn't write when I wrote it, sorry. Okay, the circumcenter is equidistant from the vertices of the triangle. So let's look at our picture for just a second. Okay, then we'll go back and start answering questions. My perpendicular bisectors are going to hit the middle of the sides of a triangle. So my perpendicular bisectors in this picture, even though it's not marked, would be XZ, WZ, and ZY. Do you see how they hit the sides of the triangles? Okay. What that means is that this point here in the middle, that point Z, is my circumcenter, which it tells you in the directions of that question. What the theorem says is Z is going to be the same distance from each vertex of the triangle. That means each corner of the triangle. Let me erase my yellow highlightings. So what that means is that the length of ZU is going to be equal to the length of ZT, and it's also going to be equal to the length of ZV. Okay, that point Z, the circumcenter, is going to be the same distance to each corner of my triangle. Not to each side, but to each corner of my triangle. Everybody ready to start working through this problem? Okay. Now, it's asking, if you notice, it asks me for several different pieces, the lengths of several different segments. So I'm going to start with my picture, filling in what we can. and then we're going to go back and figure everything else out. You guys remember the Pythagorean theorem? Remember hearing it at least? A squared plus B squared equals C squared. We're going to use that here in a minute too. So first of all, each segment, each side of my triangle. Whoops, I did that. So I'm going to focus on this one. If I can get my highlighter to work, it might help. What does it tell me the length of that segment is? 34, okay? Does everybody see the 34? Now, let me ask you this. Y is in the what of that? The middle, yes, because our perpendicular bisectors hit it in the middle. So with that being said, could I figure out what each one of the smaller segments are? Okay, and we do that by taking 34 and cutting it in half. What's half of 34? 17. So each one of these pieces are 17. Okay, so far so good? All right, I'm going to look at this top segment up here, TU. Do I know the length of the whole thing? No. But can I figure out, do I know half of that segment? I do. What is half of it? 19. So that means TX is also going to be 19, right? And then if I look at this other side over here, TV, do I know anything? Do I know the whole thing or half of that one? I don't, do I? Okay, so I'm going to hold off on that side for right now. Now, I do know that Z is the same distance to U, to T, and to V. Do I know either of those segments? Do I know the length of ZU? Is it given to me? No. Do I know the length of TZ? No. Do I know the length of ZV? Yes, what is it? 21. So that means, guess what ZU is? 21. And guess what TZ is? 21. So far, so good? All right, we're going to pause there, and let's go start answering questions to see if we can. We're going to answer what we can is what I'm meaning to say. Okay, so we have our picture labeled with everything we can figure out at this point. TU is the first thing we are looking at. I don't know the whole TU, but I do know each half. So what can I do with those two? Add the 19s together. What's 19 plus 19? 38. So guess what TU is? 38. Whoops. Write the correct letter. It might be right. All right. Go to the next one, VY. Look at our picture. Look what we have labeled. Do we know what the length of VY is? What is it? 17. What about UZ? Do I know the length of UZ? 21. What's the next one asking me for? WV. Do I have that one labeled? No. Okay. So this is where we have to think about our Pythagorean theorem, and let me talk to you about why. I'm going to blow my picture up again. We are looking for WV. I don't know what it is, but I'm going to call it X. But I want you to focus on this right here. Because Z is on my perpendicular bisector, what kind of angles are going to be right there at W? Right angles. So that yellow triangle that I just highlighted, what kind of triangle is it? A right triangle. And in a right triangle, we can use the Pythagorean theorem. Okay, and that looks like this. A squared plus B squared equals C squared. We just have to know which piece is which. So what I'm going to do is I'm just going to kind of draw this triangle outside of my picture just so I have less to look at. This is W. This is Z. This is V. I know that WZ is 15. I know that ZV is 21, and what I'm looking for is WV. I'm not saying you have to draw that triangle separately, but sometimes I feel like having less to look at is easier. So let me ask you this. In my a squared plus b squared equals c squared, which one of those is supposed to be my hypotenuse, A, B, or C? Yes. Your hypotenuse is always put in the place of C. And remember we talked the other day about the hypotenuse being across from what angle? The right angle. So look at our triangle. What is the length of the segment that is directly across from that 90-degree angle? 21. Okay, look at your right angle. Directly across from it is that. So what we're going to do is we're going to put 21 in for C. With the other two sides, does it matter which one is A and which one is B? No, it doesn't. Okay. I like my variables first, so I'm going to call this side A, and I'm going to call this side B, and I'm going to set them like this, x squared plus 15 squared. And this is C. It doesn't matter which one is A and B. Okay. Everybody ready? Now we got to figure out how to solve this equation. I've got x squared plus 15 squared equals 21 squared. What do you think I should do before I start moving anything around? Would it help if I figure out what 15 squared is and what 21 squared is? Okay, so let's do that. Tell me what 15 squared is. What is 15 times 15? 225. Okay. And then I need to figure out what 21 squared is. 21 times 21. 441. So we're so good? Now, if I want to get x squared by itself, what would I need to get rid of? Yep, I want to subtract that 225 over to the other side. $215? 216, thank you. Is that what x is equal to, though? No. No, that's what x squared is equal to. So think about this. To undo a square, I have to take the square root. So what I'm going to do is I'm going to take the square root of both sides. Okay, you can only do that in a calculator unless it's a perfect square. 216 is not a perfect square. Okay, so the square root of x squared is just x. And what I have to do is I have to go to my calculator and I have to punch in the square root of 216. And we want to round it to one decimal place, one number behind the decimal. So in my calculator, I'm going to do the square root of 216. If you don't have a calculator, your phone, if you turn it sideways, has the square root key on it. You'll just have to enter 216 first and then hit the square root button. When we take our quiz, obviously you can't use your phone, so you need to make sure you know how to do it on the calculator. Mm-hmm. Hit second, and then you see where it has the square root. So hit that square key. So put that square root, and then do 2. And we want to round it to one decimal place. In my calculator, this is what I get. I get 14.69, but I want to round it to that first decimal place. What is that 9 going to make that 6 turn into? A 7. So the length of that segment is 14.7. which means the other part is also what? The top part would be 14.7 as well. Okay, so let's go back and see. We know that WV we said was 14.7. How would I find TV? 14.7 times 2. Oops. And that gives me 29.4. So you're going to have to use the fact that you have midpoints on the sides of your triangle. The fact that your circumcenter is the same distance from your vertex. And then you're going to have to maybe do the Pythagorean theorem. I'm not going to make you do it a lot, but you're going to have to do it some. Okay, so what I want you to do is I want you to start the exact same way we started with the first one. Look at your picture. Fill in all of the pieces that you can without doing the Pythagorean theorem for now. Okay? Using the midpoints, using the circumcenter is the same distance from my vertex, or my vertices is plural. What point there is my circumcenter? H. So H is going to be the same distance from C as it is to D, as it is to B. And I have my midpoints on the sides of my triangles. So I need for you to go in and fill in the parts that you can before we have to get to the Pythagorean theorem. Let me get our homework. Bottom segment. The whole thing is how much? 24. So what would each piece be? 12. Okay. And then looking here on the left side, it tells me that CE is 7. So what would EB have to be? 7. Okay. Which means CB, the whole thing would be how much? 14. Okay. Do I know any part of that third side of the triangle? No. No. But I do still know that H is the same distance from C and D and B. Do I know either one of those segments? How far is H from B? 13. So guess what CH would also be? 13. And HD would also be 13. Okay, so that's all I can fill in before I go to the Pythagorean theorem. Let's see what questions we need. First of all, A says, what is GD? What did you label GD as? 12. Okay. BC we labeled as 14. What about EH? Do we know EH? No. All right, so again, I'm going to focus. I'm going to highlight my triangle, and I'm going to draw it over here to the side, just so I have more room to work with and less to look at. That's B, that's E, that is H. What is the angle? Which one is my right angle? At E? Okay, we know EB is 7. We know BH is 12. Just kidding, 13. And we're looking for EH. So I'm going to call that X. First things first, we need to figure out which one of those is my hypotenuse, so I know what to put in the place of C. Which one is the hypotenuse, 7X or 13? 13, okay, because it is directly across from the right angle. So we're going to put the 13 squared here. And then the other two, the order doesn't matter. I like my variables first, so I'm going to put it first. But I could also put 7 squared plus X squared. Okay, what I want you to do is go through and finish solving this, just like we solved the previous Pythagorean theorem question. You got to get rid of your squares first, then get the X squared by itself, then use your calculator to find the square root. If it's a decimal, we want to round to 1 decimal place. What is 7 squared? And 13 squared is? Mm-hmm. And then if I subtract, I get x squared is equal to 120. And then we need to take the square root of 120 in our calculator. Ooh, this one's going to be a little tricky. When I do that, in my calculator, I get 10.95, correct? All right. Looking to round to this decimal place, what is that 5 going to do to that 9? Makes it a, well, what's after 9? 10. So it's going to make the 9 a 10, but you can't do that, so we're going to carry that 1 over, and it actually just makes that 11.0. So 10.95 would round up to just be 11.0, or technically you could just put 11. Okay, so EH is going to be 11. Does that mean that's the same thing as FD? Look where FD is in your picture. Does that have anything to do with that yellow triangle? No. So we're going to have to look at a different triangle. We're going to have to do the Pythagorean theorem again. So again, I'm going to draw my triangle out separately. This is H, this is F, this is D. F is where my right angle is. FH they said was 3. HD they said was 13. We want to find FD. It is not congruent to GD.
BD. Oh, okay.
No, because the sides of the triangle aren't the same. Not with perpendicular bisectors anyway. Does everybody see where I got that triangle from and where I got all those figures from? All right, so we're going to call FDX. Again, the very first thing we need to do is figure out which one of those is my hypotenuse. What is directly across from my right angle? 13. So the other two, again, the order doesn't matter. I like my variables first just because it looks better to me. So finish solving that one for X for me. Square everything, subtract over what you need to, take the square root, round it to 1 decimal place. This should be 160, not just 60. What's 3 squared? And 13 squared is 169. So if I subtract that 9 over, I get x squared equals 160. Then I need to take the square root. And in my calculator, that gives me, rounded to the 1 decimal place, is 12.6. So FD is going to be 12.6. Whoops. And then CD, how would I find out what that whole segment is there? The one I just highlighted in green. If FD is 12.6, what would the top part also be? 12.6, which then would make the whole thing 12.6 plus 12.6, 25.2. So some of the segments there you will just be able to tell based off of the information given, and then some of them you will have to use your Pythagorean theorem to solve.